Good morning. Hi. How are you today? I am good.
Hey, everybody, it's Monday, and this is In Case You Missed Psychology. If you're watching this, that means you couldn't come to class today, and that's okay. Hope you're well. Hope those are around you are well. Hope you had a decent weekend. A little rest this weekend, kind of relaxed, did a few simple things, but, I wouldn't say I accomplished a darn thing, and that's okay. Little low energy this morning, though, not going to lie. I don't know. So, I'm going to run you through everything we did today in class, and we only have 7, well, if you count today, 7 left, before winter break. And so, yeah, well, here we go. So for starters, we started off with I guess it's number 8, journal number 8, and here, hang on, just so I know. Oh, it's the 14th, my bad. Okay, so today is 12/14. This is journal number 8, and the shortened version of the topic is chase, not the person. So what you're going to do today is you're going to write for 8 minutes, and you're either going to tell me about a time you were chased and why and how it ended, or you're going to make up a story. Well, just make up a story. It'll probably be more fun. Make up a story about being chased. Give me the why, the what happened, and how it all ended. Okay, it can be on foot, it can be in cars, it can be action movie quality if you want it to be. But just remember, you only have 8 minutes. Okay, so yeah, go ahead and do that. And if you want to pause the video and write right now, you could do that. Otherwise, you could do it later. But remember, the reminders of the Dream Project are, keep writing down your dreams. We are now under a month. It's the first time I've been able to say that the whole time. We're under a month to the due date. So make sure that you are, working on that and getting those journals done. Okay. Any late work that you might owe me, intro to the nervous system, anything like that, make sure you're getting that in. I appreciate that stuff. I grade it when it comes in and get it in the grade book for you. Be checking your grades on Infinite Campus whenever, whenever it seems appropriate. Remember, we've got, if you count this week, we got 3 weeks and 2 days. We have 17 days left of school before the semester ends. Okay. So today we're going to look at the central nervous system and the peripheral nervous system. And if we have any time left, use that as work time for the lobes of the brain assignment that's due tomorrow by midnight. And again, as always, if you have any questions, please reach out. I'm more than happy to help if you do. A little Bob Kelso from Scrubs with the Monday morning work mood for me. All right, so here we go. So today what we're going to do first is we're going to look at the central nervous system, kind of a general overview. This stupid screencast bar is in the way, though, so I'll tell you what that bottom thing is talking about. But your central nervous system is made up of your brain and your spinal cord. So you got that 3-pound mass and then the spinal cord that runs the length from your brain all the way down to your coccyx, which is your last vertebrae, or your tailbone. Obviously, it is extremely important to your survival, and any major injury to either part is considered catastrophic. Now, catastrophic doesn't necessarily mean you're dead. It just means that it's going to massively affect the way that you operate. Obviously, this is one of the reasons that when there's an injury to the spinal cord or the neck, they're so very careful, and we'll talk about that a little bit. A little bit later in the slide, we'll look a little bit at this structure diagram I've got over here. Okay, so obviously, with the spinal cord, all messages that go to and from the brain have to travel on the spinal cord. That's the only way in. So even if something is touching me on top of the head like this is right now, it's not just going to go somehow through my skull into my brain. It actually has to travel down my back to the back of my neck, get to the spinal cord, and then inside. So we don't always have the most direct paths because of that, but everything has to travel on the spinal cord to get to the brain. It's like if your brain is the city, the spinal cord is the only interstate in. It's the only way to get in and out. So obviously, that's probably the simplest breakdown. We're going to go more into the brain tomorrow through Friday. Okay, so I really kind of want to talk a little bit about the spinal cord today. And so obviously we know that sometimes the spinal cord has to act alone without the help of the brain. It has to make a snap decision or a snap movement to protect you from something. We call that a reflex. Obviously, by definition, a reflex is an automatic behavior of the body that's activated by the spinal cord without the use of the higher brain. These are usually obviously danger-related type things or places where something hits nerves that are a little bit more exposed, like when a doctor uses the reflex hammer on the leg, or there's a reflex, if you've, not that you've ever done this, you're too young probably, to have torn your Achilles tendon, they lay you down and they just They basically take something and run it the length of your foot, like the reflex hammer a lot of times. And if the foot doesn't move, you've probably torn your Achilles tendon. Obviously, there's a million examples of why you'd have reflexes. Someone goes like this in your face, and you like there, your spinal cord is making you move without your brain. Okay. If you've ever burned your hand on something and you pull it back, if you've ever stepped on a nail and pull your foot back up, all those things would be examples of reflexes. And the reason why we're able to make those movements so quickly is there's longer and more direct nerves in the spinal cord that can dictate movement in emergency situations to protect you. Once the movement has been made, then the brain is messaged of what happens and then makes a secondary response as to like what is it that needs to get done now. Okay. The bottom click of the slide basically says some species can survive for a time without the use of their brain, strictly on their spinal cord. Like you take, for instance, cockroaches. If you cut their heads off, they have no brain anymore. They will walk around until they can lay eggs again. Chickens in the barnyard have had their heads chopped off and have flopped around for hours. There was actually a farmer in England, I think it was, that kept a headless chicken alive with an eyedropper, feeding it and stuff for, God, I want to say it was like 2 months or something crazy. I can't remember the exact timeline. But when we look at this stuff, obviously, I think you guys have probably all seen situations maybe in sports or car accidents where they're putting someone in a collar and putting them on a backboard and trying not to move them. One of the reasons for that is obviously this is a pretty fragile area. First of all, if one of these vertebrae in any place were to break and shear, they can almost act like a knife. And if the actual main column of the spinal cord is cut, the person that happens to would be paralyzed from that point down. All right. So if you're paralyzed from here down, obviously you're paraplegic. If you're paralyzed where your arms and legs don't work, you're quadriplegic. And so they're extremely careful not to basically cause that knife type action to happen. Obviously, I hope you guys know this from the homework. The right side of my brain controls the left side of my body, and the left side of my brain controls the right side of my body. And so there's a crossover point in the very base of the brain, upper spinal cord, where those nerves cross over. And if you were to have a cut from there, you'd pretty much knock out all movement. And so they have to be extremely careful with spinal injuries. Airbags help with that, but just the way that they take care with those things. I don't know if you guys are aware of this, but you have these little, they're kind of like gel, almost like water inflated things in between your vertebrae called discs. Discs allow them to move more easily, so they're not grinding on each other. There are people that have ruptured discs, or you can slip a disc where it actually comes out and then it can pinch, because when the nerves are leaving that area, those nerves can be pinched in between things. People that have problems with their sciatic, they have like nerve problems. In my case, I actually have a couple of these that are flat. There's nothing in between. So if I move in certain ways, my vertebrae are almost just like grinding on each other. Obviously, there's a lot of things that can go wrong. You can have stenosis of the spinal cord. Let's actually get smaller. Things along those lines. Okay. Now, the last slide is more visual than anything, and it's the peripheral nervous system. These are all the nerves in your body that are outside of the central nervous system. And what I'm going to do is I'm just going to kind of run you through this on this flow chart and explain to you what each thing does. Okay. So you have all your sensory nerves in your body that take messages to the brain. Remember, we used the word afferent the other day. All right. These are the ones that are involved in your five senses, and they take information to the brain. Then you have your motor nerves. Motor nerves are involved in movement, whether it be voluntary or involuntary. All right. Now, the motor nerve division can be broken down into two groupings. You have the somatic nervous system. Somatic nervous system is all the voluntary movements that you do. So if I'm reaching for my pencil here and I write, that's all considered voluntary movement. And the somatic nervous system is responsible for all of those things. Okay. So everything that you motor-wise choose to do. Your autonomic nervous system, they made this so nice. Automatic. Okay. These are all the things your body automatically does. These are your reflexes, but this is also things like your heart beating, your lungs functioning like they're supposed to, your organs doing the things they're supposed to do. If you think about it, most of the things that your body does, you don't have to consciously think about. And so your autonomic nervous system plays a really major role in these kinds of things. I'll throw in that there's one pretty nasty thing that can happen with this in the body. It's called dysautonomia. That's where you have a malfunction of your autonomic nervous system. You could be sitting still like this. I'm not really doing anything. I'm not doing anything that would require like my body to be on heightened alert. And all of a sudden the heart will start to race. People with dysautonomia can be running a mile and their blood pressure can drop and oxygen can cut off. There's actually severe cases of dysautonomia where the brain doesn't tell the body to like make the heart beat and things like that. People with dysautonomia generally have a little bit shortened lifespan. Most cases don't result in like just the heart stopping or anything like that, but obviously dysautonomia is a possibility. Now, underneath the autonomic nervous system, we have two other divisions. We have the sympathetic nervous system. The sympathetic nervous system helps prepare you for emergency situations. It helps your fight, flight, or freeze. And so this is what's going to give you that boost of adrenaline, or signal the adrenal glands to get the boost of adrenaline. This is what is going to get the heart beating faster to get you more oxygen. It is basically preparing you for that situation. And then if the situation is solved, you get away in the chase situation, the cop doesn't pull out behind you, when you're going 50 down Hubble, your parasympathetic nervous system will kick in to kind of calm the system down, put you back in a relaxed situation. When you hear people talk about nervous breakdowns, what we're talking about there is when the sympathetic nervous system is on high alert for too long. And so it doesn't function the way it should. If there's no resolution to the stressor, there is no relax. Sometimes that can overwhelm the body's systems and it can cause almost like an exhaustion type feeling. Okay. And we'll talk about that more in second semester when we talk about stress and stress reactions. I kind of went through this quick. I probably didn't use quite as many examples and things that I did in class. So if you have any questions about it, please let me know. Basically what we're looking at the rest of the way is we're gonna finish the dream journals on Wednesday. Okay. And then that's going to be done. It's going to be reminders, write down your dreams, stuff like this. We're going to plow through information this week. You have an assignment due on Tuesday. We're not going to have an assignment the rest of the week. We're just going to use class time to talk through things. We're going to use Monday to talk through things. The last day of class is going to be Tuesday, December 22nd, and we're going to give you guys a test during that class period. It's going to be multiple choice matching, true, false. I'm not even going to put any essays on this one. We're going to make sure that you guys get down your basic facts. Okay. So if you guys have any questions, please let me know. Otherwise, have a great Monday. I will talk to you later. Bye-bye.